All right, this is Unit 4, Lesson 3. This is more practice with parallel lines and transversals. What we're going to find here is more ways that we actually use these things in geometry. So here's what we've got. Okay, the first thing is definitions and concepts. So from problems in the previous lesson, we noticed that angles on the same side of the transversal cutting two parallel lines in the interior are supplementary. So they're talking about angle 2 and 3 and angle 4 and 1. Okay? Each one of those pairs, angle 1 and 4 and angle 2 and 3, are supplementary, which means they add up to 180 degrees. Okay? Same thing for the exterior angles, which are 1 and 4. Actually, 2 and 3 are the interior ones. 1 and 4 are the exterior ones. Since they're on the same side of the transversal, then those two also add up to 180 degrees. Okay? So example 1 says they want us to use this drawing to classify the type of angle pair to find x. Lines A and B are parallel. Okay? So angle 6 and angle 4, where the measure of angle 6 is 120. So this is 120 degrees, and they want us to find out what angle 4 is. Okay? So angle 4 is this one up here. So together those two have to add up to 180 because they're same side exterior angles. So we say simply that angle 4 plus angle 6 equals 180. And since angle 4 is represented by 2x minus 10, and we know that because this vertical angle has that measurement, then what we've got to do to find x is to simply set this up. We know that the two angles add up to 180. We know that angle 4 is represented by this. So we simply put the representations together. So we have 2x minus 10 plus 120 equals 180. Combine like terms gives us 2x plus 110 equals 180. Subtract the 110 from both sides gives us that 2x is equal to 70. So that tells us that x is equal to 70 divided by 2, which is 35. Okay? Since they didn't ask us what the angle was, but we already know that it's 60, but in any event, that's what the answer is they're looking for because they only asked for x. Okay? Example 2, angles 1 and 2. So we've got angle 1 here. It's represented by 3x minus 40. And then we have angle 2, which is up here, and it's 4x plus 10. So together those two angles have to add up to 180 because they're same side interior angles. So this is what we have. 3x minus 40 plus 4x plus 10 equals 180. Combine like terms on the left gives us 7x minus 30 equals 180. Add the 30 to both sides, gives us 7x is equal to 210. Divide both sides by 7, gives us, well, they just rewrote it, 7x equals 210. So we're going to divide both sides by 7. That gives us that x is equal to 30. All right? So let's go to the next one. Example 3. This time they're talking about angle 1 and angle 4. Okay, in this case, these are corresponding angles, and we know that 4 is represented by the 2x minus 10, so we can say that they are congruent. So this means that the measure of angle 4 is equal to 2x minus 10, which we already talked about from the vertical angles. 3x minus 40 is equal to 2x minus 10, because these two angles, because they're corresponding angles, have to be congruent. So we're going to move the 2x to this side and move 40 over here. So this gives us 3x minus 2x equals 40 minus 10. So this gives us x is equal to 30. Okay, example 4. Okay, this time we're talking about angle 3 and angle 2. Because these two are next to each other, that makes them a linear pair because they create a straight line. So this is going to give us that they add up to 180. So we have 2x minus 10 plus 4x plus 10 equals 180. Okay, combine like terms gives us 6x is equal to 180 because the 10s go to 0 when they add those together. So 6x equal to 180. So divide both sides by 6. Gives us that x is equal to 30. Okay, example 5. This time they want us to find the value of x here. So notice what they've got. We've got a parallelogram because this line and this line are parallel, and that's told to us by these arrows, and these two lines are parallel. Okay, so we have to find what we're looking for here. So we're looking for 2x is the x, and we have a 70 over here. Okay, so 2x plus the 110 this way gives us 180 because those are consecutive angles in parallel lines, consecutive interior angles. So that gives us 2x is equal to 180 minus the 110, which is 70. So x is equal to 70 divided by 2, which is 35. Okay, so look at example 6. Okay, this time they want us to find the value of y. So y is down here. It's part of this 110 degrees. Okay, but because these are parallel lines and this is a transversal, this angle right here is congruent to this 27 degrees up here, which is the alternate interior angles. Okay, so this gives us 3y equals 27. That gives us y is equal to 27 divided by 3, so y equals 9. Okay, now they want us to find the value of z, which is this angle right here. Once again, we have parallel lines that are crossed by a transversal, so this angle is equal to this angle by alternate interior angles. Okay, and here's the thing, since we know this is 27, we can subtract to get this part right here if we need to. Okay, so 2z plus the 27, so what we're going to do is we're going to add these together, plus the 70 down here is equal to 180. Okay, and that's because this big angle up here and this big angle down here are consecutive interior angles, so they add up to 180. Okay, so 2z equals 180 minus 70 minus 27, which is 83. So divide both sides by 2, so 83 divided by 2 is 41.5. Okay, that concludes the examples for this lesson. Okay, if you have questions about it, if you do not understand, the time to ask is when you come to class tomorrow. There's a parking lot for questions. There's also a time to ask, okay? And we will have our 3 questions tomorrow when you get to class. Thank you very much. Goodbye.